Hello wonderful person, this is Anton, and in today's video we're going to explore a hypothetical scenario with our Earth being very close to the Sagittarius A star, the supermassive black hole near the center of our galaxy. Welcome to What the Math. Ever since I watched Interstellar for the first time, the movie that I think would probably be in the top space movies I've ever seen, I always wondered what would it be like to actually look into your skies and see a tremendously large supermassive black hole there. Unfortunately, in that particular movie, we don't get to see this very much, except for a few moments when they are in the outer space. But we don't really get to see what it's like from the actual planet. What is it like from the planetary surface to see such an unusual object? This is why we have Space Engine. In today's video, we're going to basically simulate this. We're going to take our planet Earth and relocate it temporarily right next to Sagittarius A star. And in the video tomorrow, I'm going to show you how I did this as well. So first of all, if I go into my search box right now and I look for Earth, you'll notice that there's another Earth that I created called Earth 2. Jump to it and you find yourself right in the middle of the Milky Way. Now, the temperature here right now is minus 17 degrees Celsius, and this will actually change slightly when I move closer to the central area. But we are basically approximately 100 or so astronomical units away from Sagittarius A star, which I think is this object right there, if I'm not mistaken. As you can see, the night skies here look completely different from the night skies on the planet Earth. And that's actually for one reason only. We have a lot more stars here. Because we are in the central globular cluster, there is a tremendous number of very bright stars. And because of this, they illuminate our planet Earth to the extent where it's actually acquiring this very different sort of a hue in its night sky, but also on the day side if there is one. Unfortunately for our planet right now, we don't have a star to orbit. In other words, this is kind of like a rogue planet. And we expect there to be quite a lot of rogue planets in this particular area of space. So this might be sort of a simulation of what some of these planets might look like. Now, I actually wanted to move a little bit closer to Sagittarius A star. And so we're going to do this right now. Shift F2 to bring this menu up. And we're going to go and change the orbital parameters, which are right here. First of all, I want our planet to be much closer. Current distance is 89 AU. Let's go to maybe 4.5 or so. And if we just kind of turn around, we'll see the beauty of the black hole right there. Now, the interesting thing about this particular simulation is that I made sure that we actually have quite a high eccentricity as well. In other words, our planet is actually going to come very close to the central supermassive black hole. And also notice the temperature. We're now at 606 degrees Celsius. The tremendously powerful accretion disk that you see in the background is creating so much heat on the planet that it's basically going to get hotter and hotter the closer we move to the central black hole. Although I think we are maybe moving away. I'm not sure actually. Let's wait a little bit. We'll accelerate this just a little bit until our planet moves a little closer to the central black hole. I also want to actually decrease the luminosity a little bit because I want to be able to see the actual black hole itself. Alright, so it looks like we're now in orbit around the black hole, and you can see the planet even crosses the accretion disk. But the temperature here doesn't drop below about 500 degrees Celsius. As a matter of fact, right around here, the temperature goes into thousands of degrees, which is quite a lot higher than I imagined it would be. It's about 1200 degrees Celsius right now. So in other words, there's definitely not going to be any liquid water here. And probably no life either. Nevertheless though, I actually want to see what it looks like for us to stand right here in whatever bright object this is and look into the skies and basically see the actual black hole. So we're inside the atmosphere now, and this is kind of what it would look like for an observer standing on the planet Earth, looking into the skies and basically seeing this tremendously humongous, tremendously powerful object right there. Now the thing is, because we're actually moving pretty fast right now, we're moving at several thousand kilometers per second, we would also start experiencing a little bit of the relativistic effects. In other words, time for us would actually move a little bit differently. And so right now I actually changed the time to real time, so this is what it would look like if you were to just kind of stand on the surface and to look around. Now, in one of the future videos this week, I actually want to create this as a 360 degree video as well, just so you can kind of see what this would feel like if you were to really look around and to actually look into the skies. But for now, we're just gonna have to go with the two-dimensional video I made right now. So anyway, that's what you'd see in the skies. And as you can see, there's a lot of dilation here. There's quite a lot of bending of light around the black hole. And obviously, as we cross the actual accretion disk, it's very likely that it would just burn everything on the surface completely. So surviving rate on the planet right now is pretty low, not very high at all. Now, before we finish the video though, I actually, oh look at that, wow, this is going to be pretty amazing and pretty scary as well. But before we finish this video, I actually wanted to really take a look at something else. Oh, and look at this huge firewall approaching basically the location where we're standing right now as we advance time. This is actually quite terrifying, just seeing this inevitable death approaching you from the skies. Anyway, so what I wanted to do before we finish this video is I actually wanted to place the planet much closer to the black hole, and possibly even inside the black hole, and just to see what it might actually look like. But before that, let's actually just look for the last time at this incredible view of the central supermassive black hole Sagittarius A star in our night skies. Alright, let's do this. So what we're going to do is we're once again are going to bring up the editing box and change the orbital parameters to the point where our planet is actually now inside the black hole, or very close to the actual edge of the black hole, and that would be at a distance of about maybe 0.4 or so astronomical units. It's actually a little bit less than that, but this is pretty much the edge right here. And let's run this again. Let's actually see what it looks like if you are literally on the edge of the black hole. You can kind of see that this is pretty much as close as you can get before falling into it. The temperatures here are 3,300 degrees Celsius now, and as you can see, things actually start looking very weird. Alright, so I'm gonna run this a little bit longer just to see what happens. And I really wonder if we actually at some point are going to even enter the black hole. Oh, look at that. Yes, we did. We're right at the edge and almost inside the black hole. It's pretty crazy. So I just want to actually pause this and just to see what it looks like right from the outside. At this point, I don't even know where up it is anymore, because the black hole actually bent the directions. It bent the light in such a way that, not just the light, the actual space-time, that I can't even see anything. Okay, so there is the surface of Earth. Very difficult to see now. And this is essentially imagining what it would be like if Earth actually entered the black hole. So right here, we're inside the black hole, whereas right here, we're outside still. So pretty crazy. Definitely not a phenomenon you'd expect to experience in your lifetime. So anyway, so that's basically the edge of Event Horizon. And I think at some point it actually even enters, yeah, it definitely enters the black hole right around here. And obviously the part of Earth here would not be able to escape anymore. But because this is just a simulation, we'll be just fine. And yep, that's right. We're now inside the black hole. Well, actually, what I wanted to do is not this. I wanted to see if I can actually find a location here, somewhere around the black hole, where I can possibly place the planet Earth in such a location where we are... Oh, okay. I don't know what happened there. Oh, we're still inside the black hole. Oops. I'm trying to place it somewhere where we'll actually have a relatively comfortable condition for human life. In other words, something like 20 degrees Celsius. So let's see if we can do it. We're going to change the location, increasing the semi-major axis to maybe about somewhere around here. All right, so just under 81 astronomical units. So this is the best I could do manually. I can actually change this in the actual file to make it a little bit better. But this is a location where our Earth is actually receiving enough radiation to sustain relatively habitable conditions. Now, what this radiation is coming from is another story, because it's not actually infrared radiation in the same way we would get from our own sun. But nevertheless, at least in this particular simulation, we have now created what seems to be relatively habitable conditions on the planet. Now, because there is definitely a lot of various rogue planets in this particular location of space in real life as well, it's quite possible that some of them are receiving enough various types of energy to actually warm up the surface enough to create some sort of unusual life-like conditions, and possibly even some exotic life. In other words, there is maybe a chance that somewhere around Sagittarius A star, there is a lonely rogue planet, just like we have one right here, that actually has weird, unusual black hole-like life that was created here over what seems to be millions and possibly billions of years. Other than that though, for now at least, this is all I wanted to show you in this video. And in the next simulation, we're going to explore something else using the space engine. Anyway, thank you so much for watching, guys. Hopefully you enjoyed this unusual presentation, and you'll come back tomorrow to learn something else and to watch another video. I'll see you tomorrow. Space out, and as always, bye bye.